Welcome back. In last session, we spoke about the stack and also operations on stack like push, pop, peak or top, or isEmpty and size. These are the basic operations we can do on stack. And also we discussed about the time complexity of each operation, right? So now what we will do is we'll try to implement using C++, how we can make these changes, how we can make a how we can implement a stack and how we can do the operations on a stack, all the operations like push pop and other things. So what I will do, I will just created one C++ file here, and let's see like how we can start. So basically what I will do is I will try to include IO stream just for some operations to see out we can do in the main function. And also I'm planning to use vector to store that elements basically, okay, in a stack using namespace yesterday. Okay, so basically what we can do is we can create a class stack. Okay, class stack we can create, and we can create a one private variable. Okay, uh, actually we will try to store the integer variables, vector of int, and it is a stack. Okay, so what we will do is we'll try to implement a public. Let me off this one, and also let me move this a little up. Okay, now what we will do is we'll do the first operation is a push operation. Let me comment here, push operation. As we discussed, it will take of one time complexity, right? Okay, so what we will do is we will try to void push. It will take integer data, right? And already we have the stack, right? Stack dot push back of data. That's it. This much only, right? So we are just pushing at one end, that is back basically, and now one end, actually one entry point. So we will do the pop operation. Um, Pop operation, as we discussed, this also will take O of one time complexity, right? Of one time complexity. Okay. Now what we will do is void pop. Here we'll just check if stack should not be empty. Oops. If stack is not an empty, I mean local variable whatever we created, then what we need to do, pop back. Can you just see that we are pushing it back and popping also from the back side? That means we are doing a push and pop operations at one end, right? This is about the pop operation, and it will take of one time complexity. Next operation what we thought we had is uh, top or peak, right? Okay, we'll see that top, actually what it will do is it will try to return the top element. Okay, so here what we do, if we'll check if local stack is not empty, then return stack dot back. Again, if you observe that we are pushing element into the whatever vector we created into the back, popping also from back, and the back element that is actually the top of the element in the stack, whatever we are trying to implement. In case stack is empty, just return -1. Okay. In case of stack is empty. Okay. This is about stack. And also another operation what we talk is empty, right? Yeah. We'll return bool and we'll check is is empty, and we just return stack dot empty. Okay, that's it. This is also of one time complexity basically. This is also of one time complexity. I forgot right here. Mm, of one, sorry, of one time complexity. Okay, and is empty also. If you observe, it is also of one complexity. Operation is of one time complexity. Okay, and what else we have? At last we have size, right? So size also we did size operation, get size also. Uh, Operation also of one time complexity. Perfect. So this also returns integer, right? Size return local vector actually stack size. Okay. So we implemented all operations. Let us test this one using main method. Integer main. So let us create one stack variable, whatever class we have created. Okay. S dot push probably 10. S dot push one more element, example 9. Let us print S dot size. Size of the stack is okay. Let us see this what it will print. We are expecting size of the stack is 2 now, right? Yes, it is 2. Okay, this is the size we are able to. Let us see the other operation. Push we tested because there are 2 elements are there. Let us see the top of the element. What is the top of the element now? Top of the stack. In this case, basically, we pushed last element is 9. So top element supposed to be 9 now. Let us see that. Okay, just run this. Yeah, top of the element currently is 9. Let us pop an element. Yes, dot pop, and also see the after popping an element, what is the top element. Okay, in this case supposed to print top element is 10, right? We popped actual one element, that's correct. Top element is this one. After that what we can do is size we tested, top we tested, pop also we tested. What else we push? One, two, one, two, three, four. Four operations. And what is another one? Uh, See out is empty or not, right? S dot is empty. So in this case, it is not empty. Let us see what it will print. Oh, okay, it's empty. One element already there, right? Oh, okay, we'll see that. If S dot is empty, see out stack is empty. Okay, let us see. Okay, so stack is not empty. That's why you are able to see. You are not able to see this one. Now what I will do, I will pop an element now here. Now the stack is empty basically. Let us see that. If you see, stack is empty now because we popped element here, the top element. So this is about C++ implementation of stack with all the operations and its time complexity. In next session, we'll talk about stack implementation using Golang. Thank you.